At this point in the course, we did already learn about a lot of important basics that you need to know when working with Go, but one super important block of concepts is missing, and that would be control structures. In this course section, we are going to dive into certain language features, certain syntax features that allow us to execute code conditionally and or repeatedly. And for that, we're first going to dive into that conditional code execution, why we might need that and what it does for us. We'll then also have a look at a related concept and see how we can handle expected errors in our code and what exactly expected errors could be. And last but absolutely not least, we are going to learn how we can repeat the same code snippet with tiny variations maybe as often as we need to repeat it, and of course also again why that feature exists and where this feature helps us. As so often for this course section, I got a brand new project, brand new Go file and a module that I created. And the Go file is basically empty. You know that from earlier course sections already. Now in this Go file, I want to fetch some user input. I want to get some user input, and to keep things simple and just focus on conditional code execution, we'll simply get the age of the user then, and then do or output different things based on the user's age. Because that is a typical use case. You have some user input, and depending on what the user provided, you might want to do different things in your code. And of course, that's just one example. You could also be getting data from a database, and you want to do different things based on which data you got. So very often when writing code, you want to execute different code based on some condition. And that's what we'll do here. So for that, to get started, let's first of all grab some user input. And of course, that works in the same way we did it multiple times before. We can create a new variable and use the buff.io package, which we of course then also have to import to create a new reader. And to that reader, we pass OS and import that package as well, .standard_in. And then we can use that reader to get some input, because on that reader struct, which it is, we have a method called readString. And that readString method reads until a certain delimiter, which in this case again is the line break here for me. And that then will give us that user input. So here I got the user input, and I got a second return value about which I don't care at the moment, though we will talk about that return value a little bit later in this section again, because in this section this will finally become important. Okay, so that gives us that user input. As before, we might want to clean that. So we might want to set user input equal to strings using the strings package, replace, and then replace our user input string, and that here should be : of course, so that this works. So then replace our user input string and replace the line break text with an empty snippet, and then add -1 to do this for all occurrences of this line break. So now we got that cleaned user input, and let's say we expect the age of the user here. So I'll actually use the format package before we get that input, and of course therefore also import the format package up here. And on that format package, I'll use the print function to print something in the same line as the user will then be able to enter the input. And I'll say, please enter your age, white space. And therefore this user input will actually be the user's age. And hence we could rename this to user age input in all those places to make that a bit clearer. Now since it's an age, we also might want to convert it. So I'll use that strconf package, which we also used before already, and import that as well. And on that stir-conf package, we can now use the parse int function, not parse float, because the age should be an integer number, and then pass user age input to parse int to try to extract an integer number from that user input. And therefore here I got my user age then, and this also returns two return values, and again I'll not care about the second one right now. In addition, user age input also wants more parameter values. It wants to know what our base integer is, so which number system you want to use in the end. And here we can use 0 for that base, which means the base will be inferred from the number that was entered. So if it is a regular decimal system number, it will be treated as such. And then we can also set a bit size here, which basically controls how big the number may be that's entered. And I'll use 64 here, though a smaller bit size would do as well. But with that, we now do parse that integer number provided by the user, and hence we got that user age value. And now it's time for the conditional code. Because now with that code prepared here, as a next step, I wanna print different messages in the command line based on the value the user entered. And that is a common scenario, as I mentioned before, that you have different pieces of code that should execute based on different user inputs, or in general, different pieces of data you got in your application. Let's start simple here. And let's say we want to output "Welcome to the club" if the user entered the age greater than 18. If that's what we want to do, then that's something we can achieve by writing a so-called if statement, which is a very important concept or very important syntax feature in Go. For that, you use the if keyword, which is built into Go, and then you write a so-called condition. In this case, we can refer to user age, and we can then use the greater than sign to compare this to another number. For example, 18. Of course, the greater than sign is not the only operator you can use here to do that, to make that comparison. Instead, you also got greater or equal, smaller, smaller or equal, or just equal, though important for equality, you use two equal signs, not just one. One equal sign is used for assigning values to variables. For comparisons, where you want to compare one value to another, you use two equal signs, like that. You can also add an exclamation mark in front of an equal sign to check for something to not be equal. So if user age should not be equal to something else, then you could check it like this. But here I want to check that user age is greater than 18, and hence we can write it like that. Next, you add curly braces, opening and closing, and between those curly braces, you add your body for this if statement. So the code that should execute if this condition is met, and only then. So whatever you put between those curly braces will only execute if this condition here is met, in no other scenarios. So here we can again use the format package and now print a new line where we maybe say "Welcome to the club," because that's the message which I did want to output if the user age is greater than 18. If the user age is not greater than 18, then nothing will be output. The main function will just finish and not show us anything, since we have no other code in this function. And here actually we could make an argument for checking for a greater than or equal, since you should be welcome to the club if you are at least 18. Because with just greater than, you would have to be at least 19 to meet this condition. So let's convert this to greater than or equal. But of course, ultimately, it's up to you which kind of logic you want to have here and which kind of check you want to perform here. Now with that code adjusted like this, we can save all that code and then of course again execute it to run our module. And then we can enter our age. And if I enter 15 here, which clearly is smaller than 18, we get no output at all. Because, as mentioned, there is no code that would execute for that scenario. If I run this again and I enter 32 here, then I get welcome to the club as expected. So then the code inside of that if statement executed successfully. And that's in a nutshell how if statements work. But there is a bit more to it that you should be aware of. Now let's first of all understand which code executes when. As I mentioned, this code inside the if statement only executes if this condition is met. But this does not mean that other code would not execute if the condition is not met. If I add another print message, println message here, after the if statement, where I say goodbye, then this code here will always execute, no matter if you make it into this if statement or not. It's really only the code inside the if statement that is conditional. Code after the if statement will still execute even if you don't make it into this condition. So the if statement and the result of this comparison does not matter when it comes to the overall function execution. That function execution will continue no matter if you make it in there or not. So therefore here, just to quickly show this, with this goodbye message added, if we run this again, even if I do enter 15, we get goodbye in the end. And of course, we also still get that if I enter 32. So that's one important thing to note. Another very important thing to note about if statements is that this comparison here actually produces a so-called Boolean value. And you might remember that from way earlier in the course. Here, on this slide, on the top right, there is this bool value, this yes-no value. I mentioned it pretty early in the course already, but we haven't needed it up to this point. Because Boolean values are mostly useful if you do work with if statements. Because they answer a yes-no question. They only contain true or false. And that's exactly what you need for an if statement. If true, then execute some code. If false, don't execute it. And therefore, a check like this, so the check you see here, user age greater or equal than 18, actually returns a Boolean value. This is an operation just as 2 plus 2 is an operation. 2 plus 2 yields a number, 4. User age greater than or equal than 18 yields a Boolean. And therefore, you could also create a new variable, is old enough, where you store the result of that comparison, like that. And then here, instead of performing this comparison just in time, so to say, we could refer to is old enough. Because is old enough, as you see here, holds a Boolean, and in an if statement, you always need such a Boolean value. You could also just write if true, and that would be valid, but it's of course not useful. Because now this code will always execute because true will always be true. That's why you instead use the result of some comparison, like we now have it stored in is old enough. Now we still have a Boolean in there, but it will not always be true. Instead, it depends on this comparison. Now it's up to you whether you want to perform the comparison first and then store it in some variable and then only use the variable in your if statement, or if you want to perform the comparison just in time, so to say. You typically do it just in time, but storing it in a variable can be very useful if you need the same comparison in different places of your code. Because you then don't need to retype that code over and over again. Instead, you can then just use that existing variable in all the places where you are interested in the result of this check. It's as always in programming, you want to avoid duplication, and therefore if you have this exact same check in different parts of your code, storing the result in a variable and using that variable instead could be worth a thought, but otherwise performing a check just in time is probably more common, since you then don't need to look at other parts of the code to understand what this if condition actually checks. And therefore here I'll comment this out so that we still have it for reference, but I'll stick to this just-in-time check here. Now, very often when working with if statements, you don't just have code that should be executed when a certain condition is met, but you also have code that should explicitly be executed if the condition is not met. Now, adding such code after the if statement will not do the trick, because this code is always executed as you learned, no matter if this condition was met or not. So if you have code that should explicitly only be executed if this condition is not met, there also is an addition to the if statement that's useful, and it's an addition which you also find in basically all programming languages. You can add the else keyword here, and then again add a pair of opening and closing curly braces thereafter. The code between those curly braces will now only execute if this condition here is not met. So here we could then output another message where we maybe say, sorry, you're not old enough. Something like that. And now with this, if we save this code and we run it, then if I enter a value smaller than 18, we see this alternative message. And of course, if I enter a value greater than 18, then we get that other message. So now we also have a way of running some code explicitly if that first condition is not met. Now, it's also not uncommon that you might have multiple conditions that you want to check, and you want to execute different pieces of code based on which condition was met. At the moment, we check if the user is at least 18 years old, and we also have this else condition. But maybe we want to check if the user is at least 30 years old, and then output a specific message, like you're eligible for our senior jobs, whatever, something like that. And we still want to have that else message, but only if the user is not older than 18. But here we're checking for 30. So now we might want to add another branch where we check if the user is at least 18, even if he or she is not older than 30. Because if we didn't make it in there, that doesn't automatically mean that the user is not at least 18. For such scenarios, we can add an else if branch to our if statement. Again, with curly braces thereafter. However, if you use else if, you now also need to add a brand new condition. And here we could check if user age is at least 18. So now, the way to read this and the way Go will execute this is that Go first of all checks if this condition is met. Is the user age greater or equal than 30? If that's the case, this code here will execute and the rest of this if block will be ignored. No other code from that if statement will execute. This code down there, of course, will. Now, if this first condition is not met, Go will go ahead to the next else if branch in this case and then check this condition. If this condition should be met, the code in there, which we'll add soon, will be executed and the else statement will be ignored. The code down there will always be executed. If this condition here should also not be met, then Go will go ahead to the next else if statement, if there is one, because you can add multiple else if statements to the same if block, or to the else statement otherwise, if it exists, and then execute that code. So that's how that will work, and therefore here in this else if block, I'll also print a new line, and here I'll say, welcome to the club. So what I had before as well. But now we have these different branches with different conditions. And hence, if that code gets saved and we execute it, if I enter 15, I still get that you're not old enough message. But if I execute this again and I enter 25, I get welcome to the club. So this else if message here. But if I enter a value that's at least 30, then I get you're eligible for our senior jobs. So that message from the main if check. And that's how you gain a lot of flexibility when it comes to working with if statements and executing different pieces of code based on which condition is met. Now there is even more to if statements. At the moment we know that we got if, else if, and else, and that's super important. But also inside of a single condition you can combine multiple conditions. Because maybe we want to output this message if the age is at least 30 but not higher than 50, let's say. For such cases, we can combine this first comparison with another comparison with the double ampersand operator, the so-called AND operator. After this AND operator, we can add another condition. For example, user age smaller than 50. Now, this overall condition will return a Boolean, and hence this overall expression here could be saved in a variable, as we did it here. And only if both conditions are met, so this one and this one, will make it into this if statement here. If at least one of the two conditions is not met, we'll not make it in there, and Go will move on to the next branches. Now, since I added this check, checking for the age being smaller than 50, I actually want to add another else if branch where I handle the case that the user is older than 50. So here I can now check if user age is greater or equal than 50, greater or equal, because here I'm checking for just smaller than 50, so we can't have a clash here. And then I could output some other message like the best age, whatever. You can of course fine-tune this however you want. Now you can also not just combine checks with the AND operator, but you also have the OR operator. For that, let's say, for some reason, we want to print this message if the user is older than 30 but younger than 50, or if the user is older than 60, for whatever reason. In that case, you can add the double pipe symbol operator, the OR operator, and then check if user age is greater or equal than 60, for example. Now this code here will execute if this condition is met or this condition is met. And in terms of priority, how this will be evaluated, Go will always first check the conditions that are combined with AND then if this returns true, it will also have a look at the other conditions that are combined with OR. Now the OR operator differs from the AND operator such that for the AND operator, both sides need to be true. For the OR operator, it's enough if one of the two sides is true. So even if that's false, we'll still execute this code if this condition here is true. And therefore now if we save that and we run our code again, if I enter 39, I get this, you're eligible for our senior jobs. If I run 55, I don't get it. I get the best age then. But if I enter 62, I again get, you're eligible for our senior jobs. You can, by the way, also use parentheses to group checks together to clearly define which kind of combined checks should be performed first, just so that you can be sure that Go is really performing the checks in the order you want it to perform those checks. And with that, you got lots of ways of customizing your if checks and therefore lots of ways of executing code conditionally. And as it turns out, being able to check for different values in your running programs to then execute different pieces of code is a very common requirement, and you will need if statements in almost every serious program you're going to write as a Go developer. Now that we explored if statements, I want to talk about error handling. And for that, let me first of all clarify what I mean when I say error handling. Of course, you can have errors in your code, like a mistyped variable, that you should avoid at the point of time you're writing your code. Your IDE helps you with that and shows such errors. And even if you don't spot it there, if you run your program, you will get an error when you try to do so. So these are errors which you can and of course have to avoid as a developer. Simple typos and bugs like that. But there also are errors which you can't avoid as a developer. And we got a great example here in this example. We're fetching some user input here, and we are then parsing this as an integer. Now, of course, as a developer, we can't guarantee that the user will really enter a value that can be parsed as an integer. For example, here, if I execute this, instead of entering my age, I could enter max, which is not a number, and hence parsing this fails, and hence the program actually doesn't crash, but it also does maybe not behave correctly. You might remember that earlier when we worked on the body mass index application, when the user did not enter correct numbers, we got that not a number special type there. So the application there didn't show the correct result, and here it's just showing that else case message, but that is actually maybe also not what we want to do in such a case. If an invalid input is entered, like we have it here, we instead might want to show an error message to the user telling the user that the input was wrong. And these are kinds of errors in your code where the program then does not behave correctly that you can't avoid in advance as a developer because you can't control what your users will enter. And of course, that's just one example. You also could have an application that sends HTTP requests to some server, and maybe that server is offline and therefore you don't get back a response. That would be another kind of error that you can't prevent as a developer. But you can expect such kind of errors. You can consider things that can possibly go wrong and then write code that should handle those cases when things go wrong. So for example here, when we're not able to parse that user input correctly because we haven't received a valid number, then we could handle that and show an error message to the user telling the user that the input was wrong, possibly allowing the user to enter the input again if we want to. And that's where this second return value comes into play. You might maybe know other programming languages where you have built-in error support and you can raise or throw errors if things go wrong. In JavaScript or Python, that is how you can, for example, handle errors. In Go, there is no such mechanism. You don't throw errors, you don't raise errors. Instead, in Go, you utilize the feature that functions can return multiple values to return error values as second or third or whatever return values that tell the caller of the function whether that function call succeeded or if something went wrong. And if we hover over parseInt, we can actually see that. Here we got a description of the return values, and we see that the first value is the integer. The second return value actually is an error thing. And if we read that description here, for example, we also see that parseInt may return errors that even tell you what went wrong. So here, instead of ignoring this second argument, we could give it a name of error or error. It's up to you, because you are still creating your own variable here. But error or error are typical names which are often chosen, and I'll go for error. Now, what is this error thing? It's of type error. But what is this error thing? Well, let's maybe just print it to the command line so that we can look inside of it. So here I'll print error. Now with that change made, let's start by running this again, and let's first of all enter a valid age, like 19. If we do that, we see that we get this nil output here. Nil, written like this, is actually a built-in value in Go that basically means there is no value. And it's used as a null value for certain value types. For example, a pointer that you created as a variable, but that hasn't yet received the address of a concrete value, would have a nil value. So it basically means there is nothing there. And that makes sense because we got no error here, because I did enter a correct number. But now let's see what happens if I do enter something that can't be converted to a number, like my name. If I enter that, then you see I get this error description here. And that's good to know. We get nil if everything worked, and we get some description otherwise. That means that if we want to show our own error message, that we can add another if check and check if error is not equal to nil. Remember, I mentioned that there is this not equal operator. If it's not equal to nil, then we know that there is an error. And in this case, we could show an error message with print line, where we say invalid input. Now, depending on our program, we could now prompt the user for input again, or we just stop the program, which we can do by simply calling return here. We are in the main function, and whenever you return inside a function, even if you don't return a concrete value, the function execution will stop. That is what the return keyword does. It's typically used to return a value, but you can always use it to stop the function execution. Because whenever you use return, the function execution will stop thereafter. Now, since return is used inside of this if check here, the function execution, and therefore our overall program here, will only stop if we make it into this if check. So only if we have an error. If error is nil, so if we have no error, we won't make it in there, and hence the function execution will continue and will make it down there. And that is how you typically handle errors in Go. You use this special error return value, and if that's not nil, you know you have an error, and then you can handle it the way you want. And therefore, if I now save this again, if we run this again, if we enter something valid, everything works. But if we instead enter something invalid, I get my error message and no other output because the function execution stopped. Now here we see how we can handle errors that are provided to us by some other function. But of course we can also write our own functions that return errors if something goes wrong. And to show this to you, let's outsource this code here into a custom function, actually including the reader. So let's grab that code here, cut it from main, and add a brand new function which I'll name getUserAge. And in there, I'll perform all that reading stuff here. And then ultimately, in the end, I want to return the age. So I want to return an integer here and return user age, this variable. And actually here, this is technically of type int64, which is a bit more specific than just int. So to ensure that everything works, we need to wrap this with the built-in int conversion function, which will, behind the scenes, make sure that the integer we're parsing here is of type int. Now we got that error here, and we could also bring down our error handling code. But maybe we want to keep error handling in the main function for some reason. Well, then we could just return this error variable, which we get here as well, as a second return value, like that. We could, of course, also create our own error variable and set that to nil if everything is fine, and set it to some other value if we wanna create our own error message or whatever. But in its simplest form, we can simply forward this error return value which we get from parseInt. Now we just need to make sure that we adjust this return value of our function, since it now doesn't return just one value but two values. And hence we return multiple values and we add the types in parentheses. And the second value type is actually error, which is another built-in type, another type built into Go that is specifically used for such errors. If you need to create your own error, you can always use the errors package for that. And in there you find a new function where you can enter some error message, for example, invalid input, and that will then give you a value of that error type. So then you could store that in your own variable and return that variable instead. Now you would have your own error. Here I'm just not doing that because I already got such an error here through that error return value from parseInt, but you could easily create your own errors as well if that is what you need to do. And now with that custom function built, which also potentially returns an error, we can call getUserAge here in main. And then we get back the user age, but also this error here. And hence that's how we should handle the return values of that function then. And we can now still handle our potential error here in the main function. Now that we got if statements and error handling out of the way, it's time to move on to repeated code, which we'll implement with a feature called loops. Now, for that, I renamed the control structures Go file into conditionals.go and moved it into a conditionals folder, gave it the conditionals package, and I added the brand new, pretty empty, pretty basic loops Go file in which will work. Now, the great thing is that I got a little demo example project in mind for diving into loops and diving into repeated code. And we can prepare this project together because whilst preparing it, we can practice what we learned over the last course lectures. So that should be a good thing. Because I have a program in mind, a simple demo program, where we can practice different kinds of repeated code, where we will prompt the user for a choice. Our program will be able to perform a couple of different operations, add up numbers, build the factorial of numbers, and so on. And therefore, we want to prompt the user for a choice and then execute different kinds of code based on the choice that was made. And then as a next step, we'll implement loops to perform the actual operations our program should perform. Now, to get started, I will first of all define a global reader variable. Global because I want to use it in different parts of this program, in different functions. And we'll use the buff.io package for that, import it, and create a new reader as we did it before already. And then, of course, use the OS package and reach out to standard in. Now, in the main package, I then want to prompt the user for some input to make a choice about which program or which part of this program should be executed. And for that, I'll add a helper function, getUserChoice could be the function name, where I first of all will use the format package, which of course therefore also needs to be imported, where we then output some message like, please make your choice. And then I'll first of all present the user with a couple of options. So I'll print another message in a complete line where I say the first choice, for which the user then should press the 1 key on his or her keyboard, is to add up all the numbers up to number x. And the user should be able to choose that number x then, if he or she makes that choice, and then we'll build the sum from 0 up to that number. Now I'll then copy that because my second option, which I want to present to the user, is to build the factorial up to number x, so that if we enter 5, we would return the result of 5 times 4 times 3 times 2 times 1. The third mini program that I want to implement in this program, and therefore the third choice offered to the user, is to sum up manually entered numbers, so that once the user chooses this option, we ask for more and more numbers, and we build the sum of those numbers until the user stops that, until the user does not enter any numbers anymore. And we're going to write the logic for all these different options over this course section, of course. Here we're just getting started. And the fourth option which I want to present is that we sum up a list of entered numbers. So here we don't ask for numbers again and again and again. Instead, we ask for a list of numbers separated by a white space, for example, once, and then we'll build the sum of those numbers. And these 4 choices will then later allow me to show you 4 different ways of looping through various values, and you'll see why we need loops to begin with. Now here at the moment we are of course just printing something. Now we want to use the reader to read the user input. So to read a string, and as always, read until that line break character is detected. Now read string returns us that user input, but it actually also returns a second value, which we always omitted up to this point, and that second value, as it turns out, is actually also such an error value. Because here already something could go wrong. And hence we should now also accept this properly and not ignore it anymore, because in general you should never ignore potential errors, but always handle them. But then here in getUserChoice, I actually won't handle it yet. Instead, I just want to return it along with the actual user input if we have no error, and then handle a potential error in the main function later. Therefore, the only thing I want to do here at the moment is I want to check if error is not equal to nil. But if it is not nil, so if we have an error, I don't want to show an error message yet. Instead, I'll just immediately return so that other code, which I'll add soon, won't execute. And I'll return an empty string because we don't have a user input because something went wrong, and I'll return that error, which is not nil. So I return these 2 values. I return these 2 values because I'll also return 2 values if everything works. And therefore, my getUserChoice function will return 2 values. The first value will be a string, the second value will be of type error, though of course that could be nil if we have no error, just as I explained it over the last lectures. Now if we have no error, then we get some user input, and then I just want to clean it. I want to get rid of that line break character. So then here, in that case, I will use the strings package, which we also saw before already, and use that replace function to replace user input and replace all the line breaks in there with nothing, and replace that for all occurrences. And then I got my cleaned user input like that. Now, once we cleaned user input, I want to make sure that it's either 1, 2, 3, or 4, because if it's anything else, then it's also invalid, and then I want to produce and return my own error. Because then it might not be a technical error, but I know that it will be some invalid input for this application which we are writing. Because only the numbers 1, 2, 3, and 4 entered just as such as plain numbers are acceptable for this application. And we also learned how we can implement that. Here at the bottom, once we got the clean user input, I want to check if user input is actually equal to 1 as a string though, not as a number, because we haven't parsed it as a number yet. We are still operating on a string here. And I want to check if user input is equal to 1, or if user input is equal to 2, which is also acceptable, or if user input is equal to 3, which is also okay, or if user input is equal to 4, which is the last value I accept. If either of that's the case, and we can split this across multiple lines, by the way, to improve readability, like that. If either of that is the case, then I know I have a valid user input, and then I want to return user input and nil as an error value, because then I have no error. If we had an error here before, we already returned, so at this point I know that I have no error if I make it in here. However, in the else case, that we have neither 1, 2, 3, or 4 as a value for user input, in that case I'll return an empty string, because then I have no valid user input in the end, and I want to return an error object. And here I'll build my own error with help of the errors package, which is built into Go, which we need to import though. And on that errors package, we got that new function where we can now add our own error text, invalid input for example. And now we'll return this error if we have an input we can't handle. So now with that, we got our getUserChoice function. In main, I can now call getUserChoice, and I'll get back the selected choice, or however you want to name it, and the potential error we might have gotten. Now, of course, we should handle that error here. And if the error is not nil, so if we have an error, then here I again want to format and print something. I want to say invalid choice exiting, because we are exiting the program now, because I'll then execute return, which, as you learned, ends the function execution. Now, if we make it past this if check, we know that we have no error, and we can now work with selected choice. And therefore here, as a last step for this preparation here, we can now check which choice was made and perform different operations for the choice being equal to 1, 2, and so on. So I'll check if selected choice is 1, and if that's the case, I'll execute a certain piece of code. Else if selected choice is 2, and we're always operating on strings still, that's important, not numbers. So if it's 2, I'll execute some piece of code. Else if selected choice is equal to 3, we'll execute a certain piece of code. And else we know it has to be 4. It can't be anything else, because if it would be anything else, we would have created an error here at the bottom. So it can't be anything else. So we know else here means that it's 4. And in that case, I want to execute the code for this fourth option here. And now I'll just add a couple of functions here into which we'll later add the code for those different operations. And the first function will be the calculate sum up to number function. Quite long name, but I want to be clear about what this function does, and we'll add the concrete function code later. The second function will be the calculate factorial function for option number 2. Then we'll have the calculate sum manually function, and we have the calculate list sum function. And now we can just call these functions here. The calculate sum up to number function here in the case that we chose 1, because that is our first program that we want to execute then, that we add all the numbers up to a certain number. So hence we execute calculate sum up to number in that one case. In the second case, we want to build the factorial. So I'll call calculate factorial. In the third scenario, I will actually execute calculate sum manually. And in the fourth scenario, I will then calculate my list sum. And that's now the starting code for the loops feature into which I want to dive. I found it quite interesting to write this together since it allows us to practice what we learned. And therefore, I think it is interesting to write this together before we do now explore that loops feature. And here I'm just getting some yellow squiggly lines that I should remove that punctuation, and that this should be capitalized, invalid input, like this. That's just some general pattern you want to follow. So of course we want to do that here as well, so that we have more like an error code here instead of a concrete error message, which makes sense since we do write our own error message here anyways. And we could then just use this error code to show different messages based on different codes. But that's not something we gotta do here. So therefore, let's now move on and explore loops. Let's get started with loops, which allow us to repeat code. And let's understand why we might want to repeat code in the first place. For this, let's start in that calculate sum up to number scenario. Here, the goal is to let the user enter some number, let's say 7, and then we want to add up all the numbers leading up to that number. And if you think about that problem, that already implies that we might need to repeat some code. We want to add a number to a number and to yet another number, and at the point of time we are writing this code, we of course don't know which value the user will enter. That's why we need to repeat code until we reached the number the user entered. That's the idea, and that's what we'll implement here. So in calculate sum up to number, I first of all want to get the number the user chose. And for that, I'll again use that reader and read a string. Read a string here. Again, using that line break character here as a delimiter. And here we got the input number and potentially an error. And of course, we quickly want to handle that error. If it's not nil, we know we got an error. And then I want to print a little message here, invalid input, for example, and return. So stop the function execution since we now can't continue. But if we make it past that, I want to clean that input and now transform it into a number. And here I'll just focus on integer numbers. So I'll transform it into an integer number. And we of course did learn how that worked. For this, we can again use the strings package and the replace function. And then use the input number, look for the line break character, replace it with nothing for all occurrences. And that will give us the cleaned input number. And then we can convert it to a number. And of course, that's an operation which we will probably repeat a couple of times, so we might want to outsource this into another utility function. But let me first of all finish it here. Let's use the strconf package to parse an integer from the input number. 0 is the second parameter value to infer the number system from the entered number. And then here I'll use 64 as a bit size, and that will give me the chosen number here in the end. And actually, we might also get an error here, so we should also handle that. Copy this here, add that, and then here maybe say invalid number input or anything like that. And now with that, we know that after this if check, we got the chosen number as a valid number. Now again, that is an operation which we probably are going to repeat a couple of times, and therefore I'll grab all that code here and actually cut it from calculate sum up to number, and instead add a little utility function here, get input number, into which I'll paste that code. And that is a function that should actually return an integer or an error. And if we got an error in here, in this function, I want to return, let's say, 0 as an integer, but more importantly, I return the error that I got. The same down there, return 0 and the error. But if we made it past all the if checks, then we know that we have a valid number. So then I'll return chosen number, however, converted to an integer by calling that int conversion function on it. And I'll return nil as an error value because we then don't have an error. And now with that, With this getInputNumber function, we got a little utility function which we can call in our overall application whenever we need a cleaned and converted number from the user input. And therefore, here in calculate sum up to number, I'll now call getInputNumber, and I'll get back the chosen number, and then potentially an error, like this. And now we just need to check if error is not nil, which means we have an error, in which case I wanna print invalid number input and return. And otherwise, after this if check, we can continue with a cleaned and converted number. As a side note, inside of getInputNumber, I of course now don't want to show those error messages. I don't want to print those error messages. I just want to return the error if we have one, so that we actually do handle it in the calling function, in calculate sum up to number in this case. And now we got the chosen number, which we can now use in a loop. Now, why do we need a loop? Well, again, chosen number is a number chosen by the user, and we now want to add up all the numbers leading up to that number. And that's where a loop can help us. So how does a loop help us here? Why do we need a loop? Because we want to repeat a certain operation. We want to add numbers up to this number, and that means that we need to perform multiple additions, so the same operation multiple times. That's where a loop can help us, and in Go, like in many other programming languages, we can create such a loop by using the for keyword. That creates a so-called for loop. Now, the for loop can take many different shapes and forms, and we'll see all those different ways of using for in this course section. But the most straightforward and standard way of using for is to use it with a helper variable that exists only for this loop, that changes after every iteration. Typically, that helper variable is a number, which then, for example, is incremented after every iteration. And we then have a condition that keeps the loop running as long as it's met. So let me show you how that works. We start by initializing that helper variable. It's a brand new variable created with the colon equals an operator, and it's created in the same line as the for keyword, and it will only be available inside of the for loop, therefore. And we use I as a variable name typically because that stands for iteration, but technically you can use any variable name you want, including longer names. But I is the convention. Then we add a semicolon. One of the rare cases where we manually add a semicolon in Go, because we add another piece of code in the same line still. And the semicolon tells Go that a new code expression starts, even though it's in the same line. This next part is the actual condition that keeps the loop running. As long as the condition is met, the loop keeps on running. And here we use a condition just as we did it in if statements. We can, for example, check that I is smaller than 5. So as long as I is smaller than 5, the code, which we'll soon write inside of the loop, will keep on executing. Of course, since I is 0, this condition will always be met. And that's why we have a third part here, also separated by a semicolon. We now define how I, this helper variable, should change after every loop iteration. For example, we could say that 1 should be added to it, or 2, or we multiply it with 2, whatever you want to do. Now here I'll simply add 1 to it. That's the most common form of changing I in a loop. And there is a shortcut for this. You can write it like that. That's the equivalent to setting I equal to I plus 1. It's simply shorter and it increments I by 1. Then we add our curly braces, and now here we can write the code that should be repeated. In this case, that should be repeated 5 times. So here we can then, for example, simply print I, and to test this, I'll also print chosen number outside of the loop so that we don't get any complaints because this variable is not being used. And with that, we have our first dummy loop in place. Now let's give this a try. We can run this program, and we are then prompted to make a choice. And here we want to choose 1 because that's the only function where we actually wrote some logic up to this point, our dummy loop logic. So I'll enter 1 and hit enter. And then we enter any number of our choice, for example, 1 again, doesn't matter. And now we see this. Now we see that this seems to work. Here we see the output from our loop. 0 to 4, 5 is not a value we see because we only keep on looping as long as I is smaller than 5. If it's equal to 5, we'll quit this loop execution. And that's why we see this output, and that's how a loop generally works now. Now there's one little change, one little adjustment I want to make, not directly related to my loop, but of course when I'm getting a new input number here, I want to give the user a little bit more information and hence actually print a little message here where I say, please enter your number. And now that's not a number for making a choice, but the number up to which we'll build a sum later. So just to add more context. And I'll also go to get user input. And here, before prompting the user for input, I also want to say, please make your choice. Like that. Now I added a little bit more information by outputting more information here. And now we are ready to work on that loop and switch from that dummy loop to a loop that actually does something useful for us. Now, how could we adjust that loop to do something useful for us? Well, instead of looping as long as we are smaller than 5, I instead want to keep on looping as long as I is smaller than chosen number. So I'll replace 5 with chosen number. Now if the user chooses 10, we will keep on looping as long as I is smaller than 10. Now since I want to add up all the numbers, I will actually start at 1, because adding 0 won't have any effect. And I'll keep on looping as long as we are smaller or equal, because I want to include the number chosen by the user. I don't want to exclude it. Then I'll add a sum helper variable, which starts at 0. And I want to change that sum with every loop iteration now. So sum is then equal to the old sum plus I. And I will change with every iteration because we are changing it here. And then once the loop is done, once we reach the next line of code thereafter, I can therefore print my result. I can say result and then output that value which is stored in sum. Something like that. And now with that, we're using what we learned in the last lecture to solve this concrete problem and to add this specific feature to our demo app. Now we can build the sum up to a certain number chosen by the user by simply going through all the numbers up to that number, by looping through all the numbers up to that number, and then by repeating the same operation with different numbers for all those numbers. And then we output the result in the end. And hence now with that, if we run this again, and I choose 1 here, and actually let me quit this, looks like I have a tiny error here. Please make your choice. That's being prompted in the wrong place. Don't want to do that here in get input number. I want to do it here in get user choice. Here, right before the user makes a choice. So let's move that here. And now, sorry about that, let's save all of that again and run this again. Now we make our choice, 1 in this case. Then we enter our number, for example, 5. And as a result, I get 15 here. And that should be correct because 5 plus 4 plus 3 plus 2 plus 1, that is 15 if you add all of that up. So that's working, and that's a great example for why this loop feature exists and why we might want to use it. Now that's the most basic form of a for loop. Now I want you to apply what we learned and also implement this calculate factorial function. And do just that, calculate the factorial. So that, just in case you're not sure, If the user enters 5, you should calculate 5 times 4 times 3 times 2 times 1, and then output the result of that. That's what you should implement now, again by using a for loop. And I'll give you a couple of seconds to pause the video and try this on your own. Thereafter, we'll implement this together. So, did you succeed? Let's now implement this together. For this, we can actually copy large parts of the calculate sum up to number code. I'll actually copy everything and I'll then adjust the code where needed. Of course, we might find a way of refactoring this a bit to outsource some shared code into an extra function that's then reused. But I'll just copy the code for now and add it here to calculate factorial. Now, indeed, the user there still should start by entering a number, the number up to which we want to build the factorial. We want to get that input number so we can use that function again. We want to check for errors and show our feedback if there is an error. And then here, in the end, don't need to output chosen number anymore. We want to build the factorial with help of such a loop. And that's now fairly easy to do. We're not building the sum anymore, but instead the factorial, if you want to call it like that, and use that variable name here and here. But we still need a loop where we loop through all the numbers leading up to the chosen number. But this time, we want to multiply those numbers with each other instead of adding them together. So here we simply use the existing result that we got and multiply that with I. Though there is one important adjustment, we need to start at 1, not at 0, otherwise we'll in the end multiply everything with 0 and therefore get 0 as a result. So we need to start at 1 here as a starting value for factorial. And then when we loop through all the numbers, in the first iteration we'll have 1 times 1, so we get 1 as a result. But in the next iteration we'll have 1 times 2, so we get 2. In the iteration thereafter, I will be 3, and the previous result was 2, so we have 2 times 3, and so on. So that should do the trick. Hence, we need to make sure that calculate factorial is being called here if the choice is 2, and that is the case. And therefore, we should be fine. If we now save everything and we again run this code, now we can choose the second option and enter our number, maybe again 5, and I get 120. And 120 is correct because that is 5 times 4, which is 20, times 3, which is 60, times 2, which is 120, times 1, which is still 120. So that is working, and we now again implemented this with help of the for loop, which, as you can tell, is therefore quite versatile and helpful. And of course, that's just one example where a for loop can help us. In practice, as you write more and more programs, you'll encounter more and more scenarios where a for loop like that can help you. But there also are scenarios where this kind of for loop is not the best choice. And we'll have a look at such a scenario in the next lecture. Now I want to move on with our dummy application. And the next case that we want to handle is that the user entered 3. And then we want to calculate a sum manually. We want to keep on prompting the user for new numbers, and then we want to add up all those numbers that are being provided by the user. Because choice number 3 is that we want to sum up manually entered numbers. Now, for that, we got our calculate sum manually function, which we call if the user chooses 3. But here, the for loop, as we learned it before, won't help us. Because now we don't have a target number that we want to reach by iterating, but instead we want to keep on iterating as long as the user enters numbers. That's a different scenario. Still, the for keyword and a for loop can help us. And that is a difference compared to other programming languages. In a lot of other languages, like for example JavaScript, you have while loops, which can be helpful for scenarios like that, where you want to keep on looping as long as a certain condition is met. But here in Go, we don't have a while loop. Instead, we simply have a different way of using the for loop, which is also supported. Because if you think about it, the regular for loop, which we used before, also keeps on looping as long as a certain condition is met. But in addition, we also have that helper variable, which changes with every iteration. It's all built into the for loop. Go also supports a variation of this for loop, where we don't have this helper variable, but where we instead just have a condition. And that's something which will help us here. Here we could add a new variable, for example, is entering values or is entering numbers, which we set to true initially. So it's a brand new variable which I set to true, so to the Boolean value true. And that's not something we did before in the course. Before we stored the result of a comparison in a variable, but we didn't set the variable itself to true directly like this. But now it is something we can do, because now we can keep on looping as long as this is true, and then stop looping once this is false. And therefore we'll have to write some code where we later set this to false. But here we can now also write the for loop as for, and then is entering numbers, and then opening and closing curly braces. Alternatively, we could also have any kind of check here, which we also can have in an if statement. If 5 is smaller than 10, or if variable A is smaller than variable B. That's all possible. You can also use the AND or OR operators. But you can also just point at a variable that contains a Boolean value. Because that's important. In the end here, you need a Boolean value, no matter how you derive it. And here we just start with true. Now, as long as this is true, the code in here will be executing. And therefore, out of the box, if we write code like this, we write an infinite loop, which never finishes. And that's rarely what you want, because that will cause your program to never finish. But it is what we want if we then also make sure that inside of the loop, under some condition, we set this to false. Now I'm writing it like this because I want to keep on looping to keep on prompting the user for new numbers until the user does not enter a valid number anymore. Because then we can add another variable, the sum, let's say, because ultimately we want to calculate a sum that starts at 0. And then here inside of the loop, I want to get my input number. So I want to ask the user for a number, just as we do it in calculate factorial and calculate sum up to number. I want to ask the user for a number, and I want to get that chosen number and also that error that we potentially get. And now I just want to use that chosen number and add that to my sum, so that we don't just ask the user for a number once, but we keep on asking as long as we are looping. And then here we can set sum equal to sum plus chosen number. Now we also need our exit condition, where we then set is entering numbers to false. And to achieve this, we can simply check if error is actually not nil, which means we have an error. And if we have an error, that means that the user did not enter a correct number, and that could be our exit criteria. So that here we then actually set is entering numbers to false if error is not nil. So if we have an error, then we'll set this to false, and then this condition here will no longer be met, and therefore we will not continue looping anymore. So we'll then make it out of this loop. Now, whenever you have a statement like this, where you check some condition to then set some other variable equal to a Boolean, you can also shorten this and just grab that condition here and set is entering numbers equal to that condition and get rid of the if statement. Then you avoid the extra if statement and you still get true or false as a result of this check, and we then store this here in is entering numbers. So as soon as we got an error, this will now store false as a value, and that will then exit out of our condition in the end. Now thereafter, we can therefore format and print our result colon v, maybe even add a line break thereafter with /n, and then just output the sum like that. Now we also might want to give the user a little bit more information at the beginning of this calculate sum manually function and print a new line where we say keep on entering numbers. The program will quit once you enter any other value, so that we also inform the user when this program will finish eventually. And with that, we are now still using the for loop, but in a slightly different version. And that's another way of using the for loop and another example for how the for loop can help us in specific scenarios. So now with that, if we run this program again and we use option number 3 now, we have to keep on entering numbers, and now I can enter 5, and it finishes immediately. Now why is that? Why is it stopping immediately? Why doesn't it keep on looping? Actually, because I have a tiny yet important logical error here in line 80. It's true that we don't need the if statement here, but here we should check for equality. If the error is nil, then we want to have true here because we want to keep on looping. Only if the error is not nil, this should yield false, which it then does with this kind of check, and we should leave this loop. So we have to invert this logic to make sure we keep on looping as long as we have no error, and hence this yields true, and that we stop looping as soon as we do have an error, and hence this yields false. So there was a tiny flaw in that logic I had before. With that fix in place, if I now run this program again, and I use option number 3, I can keep on entering values, and as soon as I enter anything else like max or just a and hit enter, we stop and we see the sum of all those values here. So that's now also working, and it shows us a different way of using the for loop. Now, of course, a question might be when you should use which version of the for loop, and the answer really just is it depends. It's something that will come with experience. It simply depends on whether you just have some condition that will not be met anymore at some point of time, or if you really have a concrete number of iterations which you want to perform. Even if you don't know the concrete number in advance as a developer, but you might know them from some user input, as we do here in this example which we had before. So whenever you have a concrete number somehow, this version is great. Whenever you just have some condition, like we do have valid input, then this form of the for loop is the version that's probably going to be more helpful to you. Now we're making good progress. There's just one last version of the for loop, which you also should know, since it is also rather important and common to use. We have this last function here, which should be triggered if the user chooses option number 4. And here the idea is that unlike in option number 3, we don't keep on entering numbers after each other, but instead we just provide one input, which is a list of numbers, separated by white space or commas, that's up to you. And then we want to take that list, so that array or slice, which it in the end should be, and add up all the values in that list. And that is another common use case, that you have a list of data, an array of data or a slice of data or even a map of data, and you then want to go through all the values stored in that list, in that collection, and do something with that data. For example, add it up, send it to a database, whatever your application should do. And that's also a use case that is supported by Go and the for loop, just again another version of the for loop. So therefore, to implement this, let's go to this function, calculate list sum. And first of all, I'll tell the user which kind of input we want. Please enter a, let's say, comma separated list of numbers. That's what I want as an input. Of course, as I said, you can go for other separators as well. And then here we want to get that input. Now here I won't use get input number because we'll not get a single number but a list of numbers instead. So this function, which then tries to convert the input to a single number, would fail. So instead I'll just grab this part of the function where we get and clean the raw input, and I will simply execute that here to get my input number list actually. That's a more fitting name, which I want to use here, input number list. And of course here I'm checking for errors, and I want to return if we got an error. But I then also, of course, want to, again, print a message where I say invalid input, something like that. Now with that, we get a number list in the end, and it's important to understand that when we reach that line, and we do have some valid input, we'll have some input which looks like that. A string, and then hopefully a list of numbers like that. Comma separated with no white space after the comma, just commas as separators. And very important, it's a string, not an array or slice. It looks like a list to us humans, but technically it will still be a string. So in order to work with that and to have an array or a slice, we need to convert our string, which is comma separated, or maybe white space separated, or separated by semicolons, depending on what you chose. And we need to split that string and these separated values up and transform that into a real list, into a real array or slice. And thankfully, there is a built-in functionality in Go that helps us achieve this. It's again available on the strings package, just like replace was. And here we got the split function. And that function does what the name implies. It takes a string as a first parameter value, and then as a second parameter value, the separator by which we want to split the characters or the values in the string, and it will then return us a slice of strings. Very important. Note the square brackets here. We get back a slice of string values. So here, I want to pass in the input number list, and then as a second value, pass in the separator by which I want to split, and in my case, that's a comma. And just a comma. Not comma white space, not a semicolon, just a comma. Because I expect this kind of input. If you expect a different kind of input, if you expect a different separator, you of course need to change that separator here. Now, split then returns this slice of strings, and just that slice of strings, no error. And therefore what I get back are my input numbers, a brand new variable which I create here, which will be that slice of strings. And actually that's important. I named it input numbers because I will have numbers as values, hopefully, but technically, from a type point of view, we'll still be dealing with strings here. So we still have to convert the individual string values to real numbers then to perform a mathematical calculation. But we'll do this in the next step, because as a first step, I now want to again use a loop. I now want to loop through all the values in that slice, through all those individual values that we got by splitting up that string. And whenever you have an array or slice or map, you can use the for loop to loop through all the values in there. For that, you use another special keyword built into Go, which is the range keyword. And you add range in front of the slice or array or map through which you want to loop. So in my case, input numbers. Now this then, combined, gives you two values. It's like calling a function. It returns two values which you can store in two variables, which will then only be available inside of this loop. Just as we had the I helper variable before, now we also get two variables by using that special range keyword on an array or slice or map. And you can name these variables however you want, but the first value which you get here will be the key of the value if you are looping through a map, or the index if you are looping through a slice or an array. So I will name it index. And then separated by a comma, the second value which you get will be the concrete value, no matter if you are looping through a slice, array, or map. Now we create two brand new variables, and therefore we still need the colon equal sign syntax. And then we add curly braces after this line. And this will now go through all the values in this array and give us access to the index or key and the value of the different values stored in that array or slice or map. So here inside of for, we could now print those two values to the console if we're interested, to the command line. And I will actually do that with printf. I'll print the index and I'll print the value like this, and then add a line break thereafter, and I will then point at index and value like that. But of course, that's not the main thing I want to do. Instead, I now want to sum up all those numbers. And therefore, I'll add again another helper variable, sum, which starts at 0. And I want to add the value, so the number I got here, to that sum. For that, it's just important to keep in mind that value here will be of type string, because input numbers is a slice full of strings. And therefore, we first of all need to convert that string to a number. We need to parse it. And we can do this with strconf parse int, which we also used before already. We pass value to parse int, then 0, and then 64. And that will give us the number and potentially an error. Now we'll handle the error case in a second. For the moment, I'll use that good old underscore again to tell Go that I want to ignore that value. And I'll focus on the number for now. Here, that number will then be of type int64. By the way, here we need to add a colon, of course. We got a brand new variable after all. And then this will be of type int64. So we'll still need to convert it to a regular int later. But we can now use that number to set our sum equal to the existing sum plus number converted to an int by wrapping it in this int conversion function. And this should now go through all the comma-separated values the user entered and sum them up. So if I thereafter print f, I can output result and then output the sum here in the end. And maybe also add a line break if we want to. And that should now work. If we now save that and we run this application, and we choose the fourth option, we now have to enter our comma-separated list here, like 1, 5, 10. And very important, make sure you don't add any white space or other characters in there. Make sure you really just have numbers and then commas between them. And if I now hit enter, I get 16. So that is correct. And we also see that intermediate output here, where I output the index values. These are the indexes assigned automatically in the slice, and then the values stored for those indexes. And as I mentioned, you could loop through a map in exactly the same way. Then you would just get the keys which you assigned instead of the index values. And that's now how we can loop through arrays, slices, or maps. So now we learned a lot about loops. As a last step, I want to show you one important keyword that can sometimes be helpful when you are working with loops. Here, we could have an error when we try to parse the individual values that the user enters. Hence, we might want to handle it. So here we get an error, and then I want to check if error is not equal to nil, which means we have an error. And of course here, we could return to stop the function execution. Then the entire app would quit because the user entered some invalid value here. Now, that is something we can do, but it would be even better if we could just continue and ignore this invalid value, because maybe the other values in that list are correct. And that's where Go gives us a useful keyword that we can use inside of loops. And that's the continue keyword. Continue will immediately tell Go to skip the rest of the loop code and continue with the next iteration. So here that means that if we got an error, we'll skip this line. We will not try to use that number because we know that we got an error parsing it, but we'll continue with the next value in input numbers because maybe that works. So continue is a great keyword if you have scenarios like this where you might want to skip a single loop iteration, but you don't want to quit altogether. You also have break as a keyword. That would then quit the entire loop iteration, but not the function execution. So that might still be helpful if you got more code in the function that should execute. But here we need continue to not stop the loop execution, but just stop the current iteration and continue with the next one. And with continue added here, if we now run that and we choose that option, I can enter invalid values like max in that list, and still it finishes and gives me a result for all the numbers that I entered. It just ignores that value that can't be converted to a number. And therefore, continue and break are also important keywords you should be aware of. And that's it for this course section. We learned a lot about conditionals here. We started with if statements, which are super important for running different pieces of code based on different conditions. You learned how you can write if statements, that you can have else if and else branches, and that you can also have more complex conditions here. In the end, you just need a Boolean value here, so you can also just store the result of a condition or a Boolean value itself in a variable and use that. Or you put your condition in line with the if keyword, as we're doing it here. Potentially, you can even combine multiple conditions, as we are also doing it here, to really express the exact condition that you want to express to then execute this code if that condition is met. And if statements are super important because in any non-trivial program, you will have different branches of code that need to execute under certain conditions. And then we also have loops. Loops allow us to repeat code. And as you learned, we have different kinds of loops. We have loops where we loop up to a certain number or down from a certain number, but where we in the end have a fixed number of iterations. But we also can write loops where we just have some condition and will keep on looping as long as that condition is met, and will therefore have to make sure that at some point in our code we ensure that it's not met anymore. Otherwise, we'll have an infinite loop, which is rarely what you want because then your program would never finish. And we also learned how we can loop through a list of values, through a collection, like an array, a slice, or a map, with the special range keyword, and then these helper variables that we can assign to the returned values, the index or key and the concrete value. And that's useful whenever you have a certain operation that should be performed for every value in a collection. And with that, we learned about loops and if statements, two super important features. If statements also help us with error handling, something we have been doing a lot then since we learned it, since you should of course also handle cases where things can go wrong and you have no control over it as a developer. You can't prevent it, but now you can at least handle it. And therefore, these are more key building blocks which you will need in basically any program you're going to write.